In this video, I will show you how to solve trig equations such as this one. Throughout the video, I'm going to be referring back to two charts of information that you need to have memorized. One is a chart of Pythagorean identities. The yellow ones you need to have memorized for sure, and the other ones are just variations of the yellow ones. But you should be able to make a chart like this in under a minute. Also, I'm going to assume that you have memorized these values as well. Or at the very least, you should be able to make a chart like this one in under a minute. Now, for problem number 5, I'm noticing that we have all sine, right? It's not a mixture of sine and cosine or anything, so that's great. And we even have 0 on one side. So I think we are ready to factor. So let's go ahead and go for it. Trinomial like this, I'm thinking binomial times binomial. How about you? Let's go for it. So 2 sine squared can only factor as 2 sine x times sine x. 1 can only factor as 1 times 1. Now inner plus outer must equal middle. Inner, I have 1 sine x. Outer, I have 2 sine x. I'm trying to get a middle of 3. I will get a positive 3 if both of these are positive, which means both of these would be positive. And positive 1 times positive 1 is positive 1. So that works out great. So now that we have factored, we can find our solutions using the zero product property. In other words, set each factor equal to 0. So 2 sine x plus 1 equals 0. And also sine x plus 1 equals 0. Solving the left-hand side means subtracting 1 from both sides. So 2 sine x is equal to negative 1. Dividing by 2 gives us sine x equals negative 1/2. On this side, I'm subtracting 1, so sine x is equal to negative 1. All right, now, the sine of what angle is equal to 1/2? I'll worry about the negative later. Well, I have memorized that the sine of pi over 6 is 1/2. So that tells me that pi over 6 is my reference angle. So I'm just going to draw a quick diagram of pi over 6. A bunch of pi over 6's, man. So those are pi over 2's so far. Whoa, that last line was janky. But you know what? I'm just going to keep on going. So these are pi over 6's. So these 4 angles have a reference angle of pi over 6. But a sine is a y value, so these 2 angles will give me positive 1/2, and these 2 angles will give me a sine of negative 1/2. Well, you heard what I just said. These 2 are going to be negative. Alright, you know what? I yawned just now, and it made me remember that somebody commented on YouTube. They were like yelling at me for yawning, and my feelings were hurt. And I hope you guys understand that I'm making this video at 11 o'clock at night. I've been grading papers all day. It's so difficult. So if I yawn while I'm making this video for you, don't be ungrateful. Deal with it. Anyway, what was I saying? I lost my train of thought. So these angles are called, let's see, so this would be 7 pi over 6, so that's going to be one solution. So 7 pi over 6, because this would be 6 pi over 6, 7 pi over 6. All the way around would be 12 pi over 6, so this is 11 pi over 6. Had the nerve to yell at me for yawning. You know, if a man is yawning, you know what that means? that means that a man is tired. And if a tired man is making a video anyway, despite being tired, you know what you say? You say, thank you. That's what you say. You don't criticize the man. I can't believe you yawned in the video. So unprofessional. You know what? No one's paying me for this. Goodness of my heart, man. I'm upset. This is 1, 0. This is 0, 1. This is -1, 0. And this is 0, comma, -1. So we want the sine to equal -1. Sine is a y value, so we're looking for the y value to be -1. So that's only going to happen here at the bottom. So that gives me one additional solution. And this is 3 pi over 2. So in addition to the two solutions I already have, I've got 3 pi over 2. So these are my 3 solutions. Okay, let's keep going. That was number 5, by the way. Alright, number 6. Slide to the left. Okay, oh my goodness, this is going to be something else. This is next level, people. Brace yourselves. I have sine and cosine. Okay? However, so clearly I need to do some type of substitution to make this work, because I can't solve it with sine and cosine like this. However, nothing is squared, and all of the things on my Pythagorean identity chart, everything is squared everywhere. So I don't know what to do. I'm trapped. I can't get out. It would be nice if these things were squared. I don't know. What if I squared both sides? Is that even allowed? Well, sort of. Okay. If you square both sides, sometimes you create solutions that don't actually work. However, if you come up the solutions that we're going to come up with using this method, all of the actual solutions will be among them. So, but if you square both sides like this, you do have to check each answer and make sure that it actually works. That's the only thing you have to watch out for here. The other thing is a common mistake. Many students think they can just square this and square this. So, oh look, sine squared x plus 1. No. If I'm going to square this side, I have to do sine x plus 1 times sine x plus 1, like this. Now this is simply cosine squared x. But this has to be foiled, double distributive property, whatever you want to call it. I need to do this to it. So sine x times sine x, that's going to give me sine squared x. Sine x times 1 is sine x. 1 times sine x is another sine x. And 1 times 1 is 1. And that equals cosine squared x. Like terms right here, so I have sine squared x plus 2 sine x plus 1 equals. Now I'm going to go ahead and do that substitution I spoke of earlier. Cosine squared x, look at my identities. Cosine squared is 1 minus sine squared. So on the right hand side I'm going to make that substitution. So this is going to become 1 minus sine squared x. Interesting. So I need to get everything on one side of the equation though. So I am going to subtract 1 from both sides, which is interesting because those cancel out. But I'm also going to add sine squared x to both sides. Being careful to line up my like terms. So I'm adding sine squared x. Are these going to cancel out? No, they're both positive. So this is going to make 2 sine squared x plus 2 sine x is equal to 0. Interesting. So time for the GCF, which is 2 sine x. You know what? Rather than bringing out the 2, because I have an equation that I'm solving, whereas I am not allowed to divide by a trig function. Never do that. Never think you can divide by a trig function. But I can divide by 2. And I don't feel like carrying the 2 around anymore. So what I can do is divide everything by 2. So that's just going to leave me with sine squared x plus sine x is equal to 0. Okay, I like this better. Okay, me gusta. So now the GCF is simply sine x, so I'm going to bring that out. So sine x, and that's going to leave on the inside sine x plus 1. Alright, time to use the zero product property. So here I have sine x is equal to 0, and then I'll have sine x plus 1 is equal to 0. Subtracting 1 gives me sine x is equal to -1. Okay, these will be solved by quadrantal angles. So let's draw the quadrantal angles down here, kind of out of the way. Here I have 1, 0, 0, 1, -1, 0, and 0, -1. Sine is the y value, so we want the y value to equal 0. So there's a y value of 0, and there's a y value of 0. Okay, so that gives me 2 solutions so far, and those solutions are x equals 0. Alright, that's the first one. By the way, we call it 0 and not 2 pi because that's what the direction said. So just keep following that. And then this one over here is called pi. Alright, is that pi? So that's what I have so far. But then we have sine x equals -1. Again, we are dealing with quadrantal angles. So here's my little same diagram again. 1, 0, 0, 1, -1, 0, and 0, -1. Y value equals -1. So here we go right here. That's the only y value that equals -1. So in addition to the 2 solutions that we already have, we have this third solution at 3 pi over 2. Okay, so these are the 3 well, maybe not. I shouldn't even put a box around these yet. Because, like I mentioned earlier, one or more of these might be extraneous, meaning because we got these equations by squaring both sides, there's not a guarantee that these will actually work. So they have to be checked when you get your solutions by squaring both sides. So we need to take that extra step of checking. So that's what I'm going to do right now. I don't have a ton of room, so I'm going to squeeze them in. Let's start with 0. Let's just check each of these one at a time. Alright, so I might have to erase over and over again. So let's start by checking 0. What would that look like? So looking back at our original equation, if I plug in 0 in both places, that's going to give me sine 0 plus 1 is equal to cosine 0. And I'm checking to see if this is a true statement. Well, sine of 0, remember sine is a y value, So at 0, the y value is 0. So this is 0. So I've got 0 plus 1 equals. And then cosine. I didn't mean to put theta there. I meant to put 0, but I got carried away. Let me fix it if I can. Alright, I'm supposed to be substituting 0. Okay, so cosine of 0. Cosine is the x value, so that's 1. So 0 plus 1 is 1. So I have 1 equals 1. So that checks out. So that one is good. Okay, now let's check what else we got. Let's check pi. Let's check pi. So that would mean sine pi plus 1 equals cosine pi. Alright, just plugging pi into the original equation. Let's see, sine of pi. So here's pi. Sine is the y value, so that is 0. So again we have 0 plus 1. Now cosine of pi. Cosine is the x value, so that's going to be -1. Cosine is -1. Uh-oh, trouble in paradise. Okay, so here I'm getting +1 equals -1. That's a no. Okay, those are not equal. In fact, maybe I'll just put a not equal to sign right here. Okay, so this one did not check out. So pi did not check out. So I'm going to have to throw that solution right on out. Okay, so let's check one more. Let's check 3 pi over 2. Okay, so we're going to check 3 pi over 2. See how that goes. So once again, that means we will have sine 3 pi over 2 plus 1 equals cosine of 3 pi over 2. Alright, just like all the other problems, but this time with 3 pi over 2. So let's see. Here's 3 pi over 2 at the bottom of the picture. Okay, so sine is the y value. So that's -1. So here I have -1. Sine of 3 pi over 2 is -1. So I have -1 plus 1. And then I've got the cosine of 3 pi over 2. Well, the cosine is the x value, and that is 0. And, well, what do you know? -1 plus 1, that is 0. So I get 0 equals 0. Okay, so that checks out fine. Okay, so in the end we're left with 2 solutions. Okay, so I really can just take this pi solution and erase it because really I only have 2 solutions because the pi one just didn't work out. So just remember, if you have to solve by squaring both sides of the equation, one or more of your so-called solutions may be extraneous, meaning they may not actually work. So in that case, it is mandatory to check your answers like I just did. Alright, now that makes this video long enough. So I'm going to go ahead and put a stop to it. But we will continue. I have plenty more problems to do coming up on the next video. We're going to get secant and cosecant involved, so that's going to be fun and interesting. So join me on the next video.